So, hello everyone. Hi, thank you for coming. Just before we start, is there anyone having any issues with their vvvv installation that would need any help? Or everyone's good? Everything working? Perfect.
Do we need the DAWs11?
Yes, I will now give this out so everyone can copy over it. There are setup files, but you don't really need the setup files. There's a folder called vvv packs. You can copy over the DX11 pack if you don't have it. And also there is a Kinect tools pack here as well. And there is a recording file under the folder XEF recordings. So if you just copy this over, we will explain how to use this later on. So I will just give this out, and then from the other side as well. So if you can just copy this over, in the meantime, I can start by asking you guys a couple of questions. So who's been in the beginner's workshop here? Great. Who does coding other than vvvv? Who does coding other than v4? Okay. Line by line coding, or again node-based visual coding? Line by line coding. Okay, cool. Who's familiar with computer graphics? Okay. Who worked with the Kinect sensor before, or any interactive projects? Something with OSC? Okay, great. This is just to understand more or less where we are as a group. So before I go over generally what we are going to cover today, I would like to introduce myself and my colleague Jürgen. My name is Onur. This is Jürgen. We are from the same master's program in Linz, Austria, called Interface Culture. And we did basically the same workshop in 4 settings over the last semester in our program. And we're very happy to do this in Node, and we're very happy to have so many people in our workshop. So the general outline of what we are aiming to do is we start out with a little bit of data manipulation and spreads. Probably you've heard of spreads by now. This is the very core of what we are going to be using. And then we start off with an introduction to 3D, the graphics pipeline, what it is, and the basic concepts of 3D space in the digital era, the digital domain. And then we will build upon the basics to start manipulating objects around this 3D world and see how these basic concepts can build together to have something interesting. And then we move on to what OSC is and how you can make use of it. And then we have a very small introduction into what the Kinect sensor is, what we get out of it as data, and like connecting all of these together to make sense of it all. Not to just have something working and have you guys copy over what Jürgen is doing with the patch, but actually make sense of how you build upon these very basic concepts and how these can make sense if you want to build your own interactive idea, project, whatever you're doing. So I think we can do a little teaser of where we will get to. The beauty of contributions is that we actually don't need any Kinect to show you what we get out of the Kinect data. With the Kinect tools contribution that you will be copying over, we are actually able to record a Kinect stream, and we can play it back as if the Kinect is working.
This is what I'm doing right now, still copying some pre-recorded data to the USB sticks to share them with you. In the meantime, we will try to solve our technical issues now, because we wanted to use this laptop, which is having trouble with the beamer, while my laptop is having trouble with its internal temperature, and also with the vvv version. So we will have to make this working in the next 5 minutes, while you can copy all of the pre-recorded data that we will use within the workshop. So we are independent from a Kinect while being able to use the whole skeleton data. We were lucky to to get to know Mio, one of the breakdancers here around. He was recording some movements for us, a few seconds, so we have some kind of a basic movement data set that we will use within the whole day, which I'm copying right now. And I hope we can get starting with building patches in the next few minutes, whereas I still have to get my playback contribution running like you now. So we're starting together at point 0.
And before I forget, one of the most important thing is that as you follow Jürgen patching, him explaining, me explaining, or me just walking around helping you guys out, the most important thing is that if you are stuck anywhere, even if you think it's a stupid point, even if you think you missed something very basic, just raise your hand, make eye contact with me, and I will come over and help you guys out. If you feel like you're not following and you think that there is this general feeling that you think if you ask this question, it might help others as well, please make the question public instead of private, because the most important thing isn't that we cover everything that we planned, but the most important thing is that you actually have this progression of building upon what is going on after the beginner's workshop or whatever basics you have.
Also, if you're maybe too fast, we will make several breaks and go through the room and everything, and we'll try to keep everyone at the same level, maybe once an hour or so. Also, there will be a break. I will try to make it the same as in the beginner's workshop. There was one break in the middle of the noon and in the middle of the afternoon session, so around 11:30 we will have a break of 15 minutes where we can then even talk more or catch some fresh air or something. And from here I would really like to get it starting, but this is now really not working and I cannot tell you why. I have no idea. And I don't even have a mouse, you know. That's awesome.
The mouse?
Mm-hmm.
Oh, because of the USB slots.
Yeah, exactly. I'm running out of USB slots. So I will copy your playback patch and the new thing now also to my here. So that we can one. Oh, there's a copy on it.
Okay.
Okay, that was fast. I can share this one. And I will try to see everything.
Yeah, but the problem is that we have more USBs, it's just that we don't have the recording data because it's large font everyone.
Oh, okay, so
yeah, I can keep it for now.
Copy everything? I just copy everything.
Just copy over the packs if you don't have the DX11 pack and the XCF file, which is the recording. Thank you.
Wenn es halt irgendwann gar nicht geht mit deinem, dann.
Ja, das Problem ist, dass der Armin wollte uns um 9 spätestens Kinect vorbeibringen. Wir haben ja eigentlich 3 Pläne, wie wir das machen können. Wir wollten ja das OSI-Protokoll erklären und dann eigentlich übers Netzwerk die Live-Daten rausschicken. Ja. Das ist jetzt schon wieder der erste Workaround, weil wir die Kinect nicht kriegen. Und das sind ja 20 Kinects für den Workshop. Vielleicht kann irgendwer, oder nachdem du schon ein bisschen advanced bist, vielleicht könntest du versuchen, den Armin zu finden und unser Kinect aufzustellen, weil das war die eigentliche Idee. Anreicht, das ist genau der Witz, und das war eigentlich ja der Plan. Ja, where's Amir's Kinect? Where's Amis Kinect? If we cannot get this running, then we need Amis Kinect, you know? And that was the basic idea.
It's not working.
No, I'm just trying to make a new folder structure.
now you need to connect.
Yes.
Do you have this number?
I have the number, but I wasn't able to get to it.
Exactly.
I have the plus 43, the Austrian number. Does he have a German one?
Well, I have the number of Fabio's colleague. I try him.
Okay. Yeah, his phone is off.
Yeah.
Okay, Fabio's as well.
Okay, once again. Let's D NODE17
Okay, how can I help? Shall I search for them? And
Sorry?
how can I help? Do you need to connect
We-
right
Yeah,
now,
we
or
are.
can you
Yeah.
start?
play.
I mean, we don't directly need it. We can start with the 3D stuff now.
We could start, but now I have it. It's working. Now let's see if we can.
If you pick the file.
But,
If it should be here, then just write
Yeah.
the name because it doesn't show up here.
Mia's read was right, no?
It was 6.
Mia number
6.xf.
Okay,
Okay, it
here
comes
it
up
is.
here.
Okay. He's having it somewhere. It's read then.
It doesn't show up.
Okay. Okay. Fingers crossed.
Takes a while.
Yeah, it's playing. That's the thing, and I had the same thing before. It's playing. You can see it, but it's not showing up. Kinect is and everything.
And if you reset Kinect or
We'll have to do that.
also enable.
Let's see. Nothing coming. It's awesome. No.
I would say let's start with the 3D stuff then, while people are copying over.
Yeah, let's
the
try this and
spreads.
let's try to find a Kinect.
But if we get a Kinect as soon as possible, that would
Okay.
be the best
Is that
solution.
Yeah. Okay.
But
Okay.
in the meantime, not to stay silent, we just start with
Yeah.
the other stuff.
Okay. Perfect. Okay. Then I go and search for them.
That would be great, thank you.
Okay. All right.
Okay, so we'll start with the graphics pipeline, or do you want to talk about spreads for a second?
What kind of example do we have? We have everything prepared for the Kinect data. I mean, I can come up with something else. Yeah.
Kann man irgendwie so ein Tick größer, wo man dann echt nicht so viel
Auflösen, gell? Genau, probieren wir das so mal. Okay, ja. Als erstes. Ja,
Die meinen sich ja gar
Okay.
nicht, aber
Mhm.
da wird man so
na kein Problem. Probieren wir es einmal mit. Oder 1024 mal 7, 8 ist 6. Gehen wir mal gleich ganz runter. Is it readable from behind or it's easier now, no? The projection, yeah, it's the distance that we have from the beamer, and they didn't put it anywhere further. And sorry for the inconveniences. The idea was to start with the real Kinect, because this is how we set up our workshop last semester at the university. That you can make some kind of crowd workshop with one Kinect, because the idea was to use the OSC protocol to send our Kinect data to your laptops, like distribute them over the Wi-Fi, and then we can use with the same data but with one Kinect altogether. What we are trying to do now is go with our backup plan, because we were not able to organize the Kinect in time now. As you can see, we still have troubles with the playback of this playback contribution, which was basically always working very nice for us. So we are now improvising. Luckily we have vvvv and we can improvise very fast, so we'll try to start with something. As the idea of this workshop was starting with 3D basics and then go over to some kind of interaction which would have been always based on the Kinect data, I will try to come up with something. But how can we do it? I mean, first of all, I think it's interesting to understand how you can navigate and explore scenery in vvvv in 3D. So what I will do now is build the first basic 3D scenery, which some of you might have seen already in the beginner's workshop, or you probably worked with it already. I don't know if you. What we always do first is we start with a renderer. In this case, EX9. If you're using the Kinect 2, we will be in the EX11 framework, but for now it's fine if you just use the EX9 contributions. And with the shortcut Alt +2, I will put my renderer inside of my vvvv patch so that we have a small visualization in there and we don't have to switch the windows all the time. So our first window is of course the output, the renderer EX9.
Excuse me, are you going to visit first Kinect because second works only with 11 like this?
With
Second Kinect works with only X11?
the X11, exactly. For now, until we get the Kinect, I will make some basic scenery in EX9. And for EX11, it will be exactly the same thing. Or I can basically start with the X11. Doesn't make sense because we will use the... Okay, so instead of that, it's true, we will use the EX11 renderer. Then we will add a group to be able to visualize several objects at once. I activate the renderer, press Alt-2 again to have it inside of my window. And there we are. I will take the geometry, in this case I will take a box, then I will use a shader.
Are you using the DX11 right now?
Yeah, now I went with the X11.
Which DX11? Several.
No, it's not that. No. So for now this is a very basic DirectX 11 setup to show the first box, and with this example I want to explain for a few minutes how a graphics pipeline in general is working, because this is how every 3D geometry is being displayed on a computer always. It's always starting with the geometry first, and the geometry itself is consisting of vertices, which are the basic data that the graphic card needs to afterwards calculate everything to visualize it on the monitor, like the material of the object that I'm using, the light where it's coming from. This is then happening in the shader, which is the second step once I have the vertices and my geometry. this geometry is not visible by default. I have to tell the geometry how it should look like, where the light is coming from, which texture, which material it should have, and this is happening in the shader. And this is where vvvv has its strength, because you can make a lot of stuff happening in the shader itself. And you are very easily allowed to write the shaders yourself. In this case, my shader is the Phong directional, which is already saying that I have a directional light. Phong is some kind of special algorithm already, which is giving us some kind of nice shiny effect on the box itself. And there are two ways now how to make this thing smooth. The one is I can transform the box, because for now we see the box, we don't even see the box.
You need a camera.
Sorry. In my renderer, it seems like we have troubles. In my renderer I can see the box already, sorry for that. The camera would have been the next step. I'm usually working with the camera soft image, because I can inside the renderer already navigate through my 3D scene. I will take it now and we'll see if this is changing something. I'm not sure. I will connect the view to the view node of the renderer, and the projection as well to the projection of the renderer. So
Okay, maybe that's buffer.
now, 1 second, sorry. You can't see anything, okay? That's the problem with the beamer now. I'm sorry for that, because I can see the box already. As you might remember from the beginner's workshop, we need a set buffer. That buffer is here, I don't know.
Anyone having issues with the installation of the add-on? The DirectX 11?
I don't have it.
Vielleicht fast duration.
Do you need the stick?
This one, not anymore. I copied everything, but can you see? I can see the box here, and I cannot see it here. I have no idea what's going on, to be honest. Really, you see, everything is working. I cannot see the box. Set buffer. Here I'm doing it with the culling. That was just the wrong option. Now you can see, at least now we have the wrong position of the light, so we only get the light from the top, which means we only see this plane. Although everything is there, I will try to change that. So it's okay. So I'm using, and this is what I wanted to explain next. I'm using the camera transform soft image, because in this case I can with some shortcuts navigate in the renderer itself in the 3D scene without having to move the camera with the input pins or something. So this is our first step of navigating in the scene. We use the camera transform soft image, and there are now 3 shortcuts. Sorry?
Could you enlarge this maybe a little bit?
The screen?
Yeah, I cannot see it actually.
The thing is,
I cannot read.
the thing is, this is the lowest resolution I can go on this machine.
Use magnifier. Do you have Windows 10 there?
Windows 8, I'm sorry.
Maybe it works with Zoom magnifier.
What was the shortcut for the magnifier?
I don't know, just type in the search field magnifier.
Windows button first.
Okay, I tried it once and it's really.
Yesterday in the workshop they made somehow
I could.
work it on the full screen. I don't know. That's strange.
We can try to go with that, but if we just
control cost, maybe it increases the.
Okay. There's Ansichten.
There we
You
are.
can choose Vollblick, Lupe or angedockt.
Thank you very much.
Ansichten.
Ansicht.
Wait. Now I have to get rid of this Bildschirm loop again. No, das ist das Ding und da, ich habe es mal probiert und dann gemerkt, das kann man für den Workshop
Ah,
nicht mehr nutzen. Ja, genau.
Ansichten, Vollbild.
Okay. Und jetzt? Okay. Okay, let's try. I don't know. So, again. I started with the classic X-Men runner. At least we have the Kinect now. So I guess some of you are still trying to build this basic patch. What I used was the.
Sorry, just a second. Whoever doesn't have it installed yet, I can help out.
Okay. I use a classic renderer EX11. This is the first window, my output window. Afterwards, I use a group. Now that we are in DirectX 11, I use the EX11 group node. In this, I took the EX11 font directional shader, which is telling my geometry how to be visualized. And on top of that, I need, of course, the geometry. In my case, I just took a EX11 box, which is a basic geometry that we can use here, and we will use it also within the workshop now. I've seen that we already got the Kinect, so there's still one problem. I don't know how with this resolution we will ever be able to build a patch with more than 3 nodes. I'm sorry, I think we will need more than 3 nodes in the end, or we can sub-patch like crazy, but also this is leading nowhere. I don't have a real solution for this resolution thing, but for now, what you also need to see the box in DirectX 11, in EX9 it's there by default, but you will need something called rasterizer, which is telling also the shader another technology how to display the geometry he's getting. For example, wireframe would be only the connections, the edges from one vertex to the other, so that you can see the basic geometry, where the shader is then interpolating the colors in between. In this case, I took the backcard simple, which is like the default. And this is what you see here. It's in EX9, if you remember, we only had a group and we could put the objects inside. Here in EX11, we also have to tell the group via the rasterizer how to display our stuff. So the first pin is reserved for the rasterizer, or in general called the render state. So this is number 1. Then, now coming to the navigation in 3D. The important part here is, I mean, there are several ways to use the renderer, to use the camera inside the renderer and visualize the scene on the renderer. But if you're setting up a 3D scenery in vvvv and at the same time you want to zoom around and pan around within the scenery, you can use the camera soft image, which I'm using most of the times, where you can either manipulate the camera, of course, via its input pins, or also if you click in the renderer with some kind of a shortcut combination. And I always have to try it myself, 1 second. If, for example, you have pressed O inside the renderer, the button O inside the renderer and the left mouse button, you can rotate the scene around the origin. Can you rotate your cube? Is it fine for most of you? The second shortcut is the P. With the P, I can zoom inside and outside. I know it's very hard to see now. Maybe I go here. So, with the P, I can zoom in and zoom out. With the O, I can rotate. And with the Z, I can pan the viewport. So these are the most important shortcuts for navigating inside the scene. The Z is for panning. The O is for rotating. And the P is for zooming in and out. I will write it here somewhere. So are you able to navigate around your box already or so? It's fine for you? Or most of you?
Can you see me again? Want the camera?
Pardon? Are you in EX11 for now? Are you using the cameras in this forum? Soft image. This doesn't matter if it's a from X11. It doesn't matter if it's image. It's 11. This camera. What you have to do next? Connect the view pin to the view. What's the second one? The second pin is the view, and you connect it to the view here. And the third one is the projection. You connect it to the projection. Everyone else able to navigate around already? Next step, but this is not gonna work. Ja, noch weiter runter. Ja, das jetzt, ich bin auf 1024 mal 768. Ja, und jetzt noch mit ein bisschen lieber, das ist, weil der Beamer 2 Meter weit weg steht. Der müsste irgendwo anders sein, ich weiß nicht. Keine Ahnung. Das ist extrem. Kommen wir da hin? Aber das ist, eigentlich müssen wir jetzt so ein Survey machen, wer wie viel Dioptrien hat und das tut so, was der, also, ja, das fällt einfach. Mehr, was nicht. Genau. Okay, this is our first 3D scene at least. Now, I don't know, it will be very complicated. This is just not working. We cannot, I don't know, you can see one node. We cannot put a beamer maybe more behind, maybe we can arrange the seating somehow. Hm? Ja, okay, aber wie kriegen wir den weiter hinter?
Wir könnten vielleicht die T-Shirts weghalten. Genau, das ist ja.
Diese Einstellung, die hier gerade benutzt wird.
Ja,
Wenn ihr die Stuhl aufklickt,
Das ist
wenn
jetzt-
jemand auf die Stühle, dann kann man da links runter noch arbeiten.
genau, das könnte man machen, dass wir von ganz hinten, dass wir dann nochmal kleiner werden. Wir kommen ja dann aus der Bildschirmlupe wieder raus.
Du musst, glaube ich, erstmal finden, wo sie ist, oder? Wo das
Ja, na, die ist eben. Jetzt, nachdem wir Fullscreen sind, ist ja. Ah, okay. Ey, mach's den nochmal zu.
nichts gibt es keine irgendwie 120% oder 130% oder
Wird auch noch gehen, aber es ist ja. Jetzt warten wir mal, bis der Beamer da angestellt ist.
What if you press Ctrl minus and Ctrl plus?
We can you try it, but yeah, we still have to. It's still a workaround. I don't like workarounds. Even if it's a node workshop, I'm not a fan of workarounds. This is the only way we can go. That's for sure.
You can arrange the
Yeah, no, it's working. We can try like this.
Yeah.
Zoom in and out whenever there's something more special. We'll go with this. It's better than nothing, that's for sure. But as you see, I really have already troubles with my own. With this, also the values are not displayed in a good way. Okay, let's plug the Kinect.
Maybe in the meantime, I can explain a little bit about
Yeah.
the graphics pipeline. So all of this makes a little bit more sense, hopefully, because not everyone is very familiar with computer graphics. So basically, a render is getting visuals out of abstract data. Because in the 3D world, in your computer, the geometry is only data. It's only saying there is something there, and then these are connecting in this way. But having it rendered means that you get all of this data and you tell the computer to process the data and then actually draw this onto the pixels of your screen. And this is the process of the rendering. And the very basics of computer graphics are called vertices. Vertices, or singular vertex, is a point in the coordinate system where you're explaining where everything is. And with these vertices, the most primitive geometry that you can draw is a triangle. And this is the most primitive, this is the most optimized thing you can draw. And a triangle basically has 3 vertices telling you where it exists, and then a normal vector which tells you which face is the front face. And by this you already tell the computer, this is all the data. And then you're telling the computer that this is my triangle, this is where it is, and this is its face. And then throughout the graphics pipeline, after you've had everything like defined with the data, once you have this, through the graphics pipeline, it goes with shaders where it computes, basically looking at where it stands and how the geometry is built and how the vertices are supposed to be processed. And then after all of this happens, you have the last point where you have the rendering. And rendering is basically rasterizing. And rasterizing means that with every screen you have different amounts of pixels, and this is hardware dependent, so you don't know where to put this thing. It's always a relative thing. So in this rasterization step, it is the final step where you have the rendering actually showing on the screen, and at this point you have everything computed, everything is now calculated, and at the very last step you actually get this pixel to be drawn here, and then you have the render. So when you hear the term render, it's the whole process basically of having this the data there telling you where something stands in this abstract world, and then at the very end you have this point drawn onto the pixel on your screen, and then you have a render. And for this, for having a common ground to say, this is where my triangle stands, and for the computer to understand this, you have a couple of things. The first thing is a coordinate system. A coordinate system is what we saw in maths in middle school, like the x and y axis. And in vvvv, it depends on different platforms normally, but in vvvv, the very center of the screen, the very center of the renderer is 0, 0. And if you go to the right, you are going to x plus 1. So the very right of the screen is x equals 1. The middle of the screen is x equals 0, and the left side is x equals minus 1. Same goes with y. If you go above the line, the middle line, it goes to y equals 1, and the very bottom is y equals minus 1. So this is your coordinate system. So once you want to place it somewhere relative to the middle point, relative to 0 and 0, then you have to define it based on these axes. And this is the coordinate system. This is how you define the general structure, the basis of where these things are supposed to be positioned. The other thing is the camera, which Jürgen already mentioned. To have this renderer and talking about the primitives and the positioning, you actually have to look at them. So normally in real life, when you have something in a position, if you don't look at it, you don't see it. It's the same with the computer. You can't really assume the computer to understand that I drew that there, so I want the computer to look at it there. You have to tell it what the angle is, what the direction is that you are looking to, so that you see it. So the most important thing is a camera, because whatever you do, whatever complex rendering you're doing, if you're looking the other way, you see nothing, and you think you're doing something wrong. So with the camera, you're actually positioning the camera in the same way that you position any kind of primitive, even a triangle or a cube. You have to tell where the camera is relative to the coordinate system, and then tell it where to look at. And if you were drawing in this field, then you see whatever you're drawing. The camera has some more specific things like projections, etc., but we don't really have to get into it. So this is the basics of having an eye and then having the world like comparable to our real world. And then the last thing is, of course, lighting, because if you don't have any light in the scene, which is like the Phong shader we're using here is a default shader, you can also write your own, which is much more complex, but gives you much more flexibility and more interesting graphics. But basically, whatever we need to see something in the real world, we really need to define it in the computer graphics world, in the 3D world, in this digital 3D area.
Here you have some examples in this list. I hope you can read it. Again, I can try to now, but the Node Explorer is not magnifying. Basic ones are constant. Phong point template is again some further leading concept. You can, for example, I will mention it for a short time. Of course, you can write your own shaders and your own nodes. And this is what the templates are for. If it's called template, it's the most basic shader you can imagine. If you want to take a look into the code, or you want to code the shader, you just make a right click onto the shader itself, and it's going to open the code window, which is the syntax is based on HLSL. High-level shader language. So if you want to learn how to do it, you can learn HLSL and implement these concepts in here like directly. Whereas here you can also see what Onur explained before, and I tried to explain that first you have a vertex. From this vertex, you have to. You don't have to remember. I will explain it for a few minutes that you have seen it. First you need a vertex. This vertex is calculated in space with its position and its texture coordinates inside the shader. Then it's passed to which is called the vertex shader, because the shader is consisting of several parts. The first one is the vertex shader, which is getting the position and the coordinates of the texture. This is passing then to the pixel shader, where you have the position and the texture coordinate again. Inside there, the coordinate. The texture is then calculated on the positions of the pixels, and in the end you also have to define which shader version for the vertex shader and which shader version for the pixel shader you want to use. And since you are working in DirectX 11, for the ones who want to work in the future with shaders, you have a lot more functionalities with VS4, PS4, with all of the things that are coming with DirectX 11. That's only that for now. So you've seen it. This is a basic template. And you will always need, for every geometry in 3D, don't forget you will always need first the geometry, then the shader. Okay. What I was able to manage now is get the Kinect running. We have a Kinect count of 1, which means although even my USB 3 port is kind of buggy, it's working now. And maybe for a few minutes, sometimes I would need someone like you to come in front of the Kinect and give us some skeleton, so that we have something to work around until the playback is installed or something that we wanted to do then. So maybe if you could do it now for a moment, let's see if a skeleton is detected. Kinect is here. Do we have the white spot? No. Okay, then we can sit down. I don't know. Is available? No. Okay, then we have this again. It would be great to enable it before, of course.
Yes, now it's on.
Now there we are. Now it's already only because although you're sitting, it's already detecting you, because that's something for the Kinect too. It's very stable, and as soon as it's recognizing something like head and arms, you already have the skeleton. Of course, the legs will be very jumpy and buggy because it cannot detect anything. But you can see that I don't know who was working with Kinect 1 already or so. You had a lot of troubles to have a stable detection and everything, and here the tracking is working super smooth. So, who of you was working with the Kinect already? Like I knew we were asking before, so not so many. I will just show some basic things that we can have with the Kinect in vvvv. For today, we will mostly all the time work with the skeleton itself, because we want the 3D data and not the camera feed or the RGB video or something. That's not what we want to need for 3D sceneries, or what we need for 3D sceneries. Let's see what's interesting. The first one was no. Yeah, here we are. This is very helpful. Whenever you have a skeleton detected, you will get the 25 joints in total with, I think it was this, with their according indices. So if you want to find out which kind of joint I want to track, you can see all of the joints that are able to be tracked here in this list with their encoding index. And some of you are beginners. You heard in the beginners workshop probably the concept of spreads already. And I will try to explain this concept a little bit further, to the point that we can use it here in our 3D scenery later. Yeah, but let's make a break. Okay. Na, jetzt haben wir ein bisschen spät angefangen, ein bisschen rumimprovisieren müssen, weil es mit der I think it's in German because of both of them, sorry. No, we had to start a little bit later because we had a problem that the beamer is like really not far away, and the resolution is super shitty for the people behind it. But I think for now it's working. It's no problem.
Because they should see the numbers,
Maybe
right?
they improvise some kind of... No, the numbers are fine.
You can zoom in somehow?
That's what we are doing then. If someone can really not read it, I hope that the people that are not so good with
Use the
using it
magnifier, use the Windows magnifier.
That's what we did before, but it's We tried, but then you lose time with magnifying instead of showing the patch and everything, and at least this kind of size should be visible so that people can see what's going on. I mean, for now, I think it's fine. Is anyone still having troubles to read the text or something?
But maybe if we close the shades, right? This is also
Please, yeah, of course. Can also, of course.
I can read it, but I think more difficult.
Let's try with maybe 12. Ah, now there's no skeleton. And now we'll introduce you to a note that the beginners won't know, maybe the sample and hold, if he's back again. Because if you want to read out values and you want to store the values temporarily in your patch for some time, like for example, I want to have the joint, would you please stay here for a moment? I want to have the joint list, although he's not tracked anymore. There's something called sample and hold. The abbreviation is S and H. Now we have to know which kind of data type, which we can read here. Joint ID, spine base, I think it's strings. Let's see, S plus H string. And what this is doing, it's very basic. It's getting data, outputting the data, and once it's set, this is usually a bang, which is only triggered once in a frame. Whenever this bang is triggered, it will store everything that's coming on the input to the output, basically inside itself. So if you go away now and we are not tracked anymore, we are still tracked. Kinect is too good for that. Thank you very much. So if we lose him now, we will still see the list and we can work with it further. The same we can of course do with our number values here if we lose him, but these are the ones that are dynamic, so it doesn't make much sense here. For the more beginners, I will now try to explain the concept of spreads a little bit further, because I know some of the faces were coming from our total beginners workshop. You have heard what is a spread, you have heard what is a slice, but you probably never heard about the term BinSize, which is like the last thing you need to understand the spread itself better. And we will have to use it now for getting our trend positions in 3D space. Also the get slice we mentioned only once for a short amount of time, so I will try to go step by step now. Here, for example, we see in the brackets we get 25 joints, which means if it should be interpreted as 3D positions, we will have 25 times 3 coordinates, 25x, 25y, 25z, which means we will end up with 75 values, which we can see here. So this is a spread now, a spread with a slice count of 75, where the first one is x1, the second one is y1, the third one is z1, and so on then for the next. So we can now use a node. Luckily we are only working with values for now. The first node we might need to get some data out there is the get slice. Get slice spreads is for using spreads with values, and this is where we ended up in the beginners workshop. You can see here out of this 75 values that are passed here into this IO box, going further into my get slice, I will get one value, and this is exactly the first value of all of my 75. This get slice is giving me the first slice of the spread with 75 values. Okay, if I want the second one, I think you remembered maybe, I can change the index. If I change the index one more, I will be at the second coordinate. If I change it to the second, it's like in code-based programming, you always start at 0 with the first element. The same is happening here with the indices. So if I say index number 2, I will get the third element out of the 75. Okay. So what we can do now? Let's just try. We can copy paste our get slice. then connect our 75 outputs again, and then say something like, okay, we want from the spine base, which is based here, as it's saying, we want to get the X, we want to get the Y, and we want to get the C. Okay, here we have, and we knew this from the beginner workshop, also here we have now X, Y, Z of our first joint called spine base. Are you able to follow until this point? Some of you, for them it's like a matter of 1 minute. Some of you have seen it the first time maybe. Are you somehow at the same point with me? Mostly? Yeah? Okay. From here on we can, for example, then say something like vector join, which is nothing more than, again, giving me a spread with a slice count of 3, and this is then called a vector in 3D. So if I join these together, I will have my vector representation of the position of the spine base. What I will show you now, I will then delete it again. But here, as you can see, we get 75 values. In the end, it's just a list. If I want to change this, I can type 75, calls row pages, and take a look of all of my positions. This is what we have here, basically. And now we have to find a way. What we did now is getting the vector of the spine base. Now we have to find a way how to come to the second set and the third set of X, Y, Z coordinates. And this is the last concept that you need to understand spreads, and it's called BinSize. So if I use the node getSlice, there's a third pin that we didn't mention before, and it's called BinSize. And this is telling me how big should the package be that I take out of my spread. How many slices do I want to take at once? It's a very important concept in vvvv, and also by practicing it will be like supernatural for you. By using it a few times for now it sounds a bit weird, but let's try it for one time. I will make another getSlice and let's see what's coming up. getSlice. We use the getSlice spreads again, connect it to our output, and this time instead of saying I will stay with the index number 0, but this time instead of saying I want to get one value on the index 0, I want to get, and this is the BinSize, 3 values at index number 0. And what I will get is again a spread of 3 now. I have to arrange my I/O box, and here I have my vector again. I get the first 3 values at the index number 0. What I was doing now is basically, I didn't say getSlice, I said get 3 slices at once at index number 0. And this is the final step to now be able to go through all of our skeleton data. Because what we can do now is, according to our list here, where we have all of the indices, we can jump now in increments of 3 through all of our coordinates. And so we can choose which kind of coordinate set do we want to have. For example, in this case, I remember here, for example, this is the outcome of my Kinect spine base. Okay. These are the coordinates of our spine base at index number 0. What we want now, for example, is, let's say, the coordinates of, what do we want? I don't know. Maybe left, wrist left, for example. We can take the hand left and the thumb left, but they're very jumpy and easy to track. So for stability reasons, we take the wrist left, which is index number 6. So let's see if it's working. We will jump the index number 6 because we are jumping in increments of 3, we are always, maybe I can also show it here for a moment. We are always jumping in sets of 3. So if we say index number 6, we go like index number 0, 1, 2, 3, 4, 5, and 3. So we jump 15 values to value number 16, 17, and 18. And this will be our set of the left hand, left wrist, and if you move your left hand, for example, now a bit, you can see the values changing here. There's not much changing in the Kinect spine because he's still sitting where he's sitting, but his hand is moving. And here you can see, for example, on the Y, which is up and down, it's going into the minus and into the plus. Now he's going forward and backward with his hand, and this is what we can see here. So we already have a data representation of the first joint. So this would be this. Now we only have values. Of course, we want to. Let's see. I don't know. We already have a very big patch. It doesn't have to be that big, but it's a possibility to, or the opportunity to show you another node that's very important if you work with bigger patches. There's something called sender and receiver in vvvv, where you can send values to another point in the vvvv patch, even to another vvvv patch, a sub patch, whatever. And it's called very easy. It's called just S for send. In this case, we want to send a value, and R for receive this value. Here, it doesn't know what to receive, and here we have just a default name. What we will do now is we send 3 values. It's recognizing, like vvv is recognizing already, it's a spread, so it knows I will send 3 values. In the second bin, I can expose it, and I can rename it. So I will rename it with the name that I have here. This is now the name, and now I have in this sender node, I have the coordinates of my Kinect spine possible to send everywhere inside the patch or anywhere else in the machine. This is not supposed for networking. There are other nodes for that. This is really only for having big patches or sending something to another sub-patch or so, where you get out of control. And this is already kind of crazy. So, okay, then we only have to say the receiver node. Where do I want to receive from? With a right click to the input pin, we say the Kinect spine, and what we will get here are our 3 values. Just copy paste. See, the values are the same. That's exactly what they should be. Now I will go back to my 3D. There are 2 kinds of transforms in 3D. The one is the transform 3D, where you can, I should show you for a moment, I think. The normal transform is having exposed the translation, also the scaling and the rotation, but the translation exposed explicitly on the X, on the Y, and on the Z axis. We don't need that because we can already interpret what we receive here, and now the receiver node makes sense. Here I want to get my spine base coordinates, which is a vector with 3 values, and I couldn't put it into the translate X, Y, Z. So this node is accepting a vector, or in another way a spread with a slice count of 3. And let's see, I will try to use this transform onto our cube. Now if you move your, this is the chest, we can make a second one. One moment. This is the spine center.
So what happens when you send the same different values into the same variable? Kind of collide?
In this case, I'm sending different values with two different send nodes.
No, before you enter the new name, you send both of them into the same.
Here, you mean?
No. Okay. That's not
Because I only had one for now. Now I have the second receive, and here you can see after I rename to second send, I can choose off the list of all the sends that I'm using, which data do I want to receive in this receive node. And here I want to have the risk because this is the. I will make another transform for now. This is also spreadable. I will show you later. But I will make a second one. Transform. Basically, that would mean. So, and if you move your hand now, this is already going with the hand. Of course, we should also. I will make a small uniform scale. Yeah, and here we have the position of our left hand. And now, since we are working with spreads, it's only a few steps more to have the whole skeleton, the whole positions of the joints visualized in our 3D scenery. And I don't know, maybe we should make a small, not a small break to go away, but make a small break to have everyone catch up or ask questions until now, and then continue with what's coming up next. The first question is coming here.
Yeah, well, it's quite noisy. Is there a way to filter out the noise?
Yeah, what we are taking here is now Kinect has already some kind of pre-calculation inside of the Kinect. This is why this is basically much more stable than you might remember from the Kinect 1. It's still kind of jumpy, and there we can remember, or maybe you heard it already, there are these filter nodes. Filter nodes are giving you the possibility to dampen signals, but also this dampening of signals or this interpolation of signals between positions is taking some time. So the smoother you want to have it, the more lag you will have between the movement, the actual movement, and the movement of the 3D box inside the scenery. For now, for showing it, to get rid of the jumps, we will use the most basic node. It's called damper. You see it's a filter for animations. It's a very easy node. I will take the transformation data that's coming outside here, or not the transformations, but the values themselves, and I will dampen them down a bit. In this moment, we already have a smoother movement. But you can see it's not following his hand accordingly, like directly. There's already some lag. We have a parameter with which you can somehow refine it a little bit, and it's called the filter time. And here, of course, if you would have, for example, one value, and you in increments, like discrete values, and you would send another value, this 1 second tells you it will always take 1 second to interpolate from one value to the next. Now we're getting continuous values, which mean it's trying to go to the next value within 1 second, but then the next value is already coming, so it's trying to dampen there and dampen there. So we have some kind of slow movement. I can, for example, try to go down to 0.01, and it will be very jumpy again, because now it's 1/100th of a second interpolating between the value before, which means that's too fast already. Let's try, for example, maybe with 0.1 and see what this is doing. This is something I can accept. It's not very jumpy, it's almost not jumpy at all, but already almost directly reacting to the movement. So this is something you can use for dampening your signal somehow. There are also other filters, but they all have the same problem, that they have some time in between to interpolate, and that's why you will never be like one-to-one connected to the data itself. For now, okay.
Small break. So we get everything into mode.
Yeah. Let's make some question break now, and I think in 10 minutes we can then make a break to catch fresh air and have a cigarette, have a coffee or something. So in 10 minutes you can maybe play around with the patch, maybe ask us some questions, maybe go one step further.
I stopped repatching this because I don't have the Kinect data, so what am I...
That's the thing, of course. Yeah, and that was the thing. This
so
is
now maybe we can
very
just
common.
go into the like 3D transformations, do it manually with spreads, like to make sense of what we are doing, so you can follow the transformations and have an understanding of what a transformation is in 3D space, and then play around with these 3D objects, and then maybe we go into the Kinect stuff and we have a different solution so that you can use the same data that he's getting here for the joints without having a Kinect.
And we have two solutions for that, so we were kind of prepared, although it seems like the opposite. But the one thing is we will either send you by network, which means we would really need your IP addresses then in the end, but the local ones from the local Wi-Fi. So we can like send you directly the values that we have here. It's 70, 75 numbers. It doesn't need the biggest bandwidth. Usually it's working kind of nice. This is the one idea. If this is not working, we have recorded some kind of basic data set with a contribution that was coming from the community, where you can record Kinect data, store it. It's a huge data set. You can have, you can record the RGB, you can record the depth, you can record everything that the Kinect is tracking, which means 1 minute of data is giving you already like 8 gigabytes. So we try to keep it down a little bit, so we will have 10 seconds of movement for you. If you cannot connect or so, you can still use this basic data set, but we will have to set up the contribution that we have on the USB sticks. It's called the recorder and playback for Kinect. And with this playback node and with the DirectX 11 pack and the Kinect installed, you can fake the Kinect being plugged in already. So you will have a dancer making basic movements, giving you the coordinates, and on these coordinates you can follow us with what we are doing here then at the same time. So this is after the break maybe the next thing to set up then and have this kind of basic Kinect data on every machine running. From there on we will then explore further how to work with the transformations in 3D, and then the idea was to do it in the afternoon, maybe we're a bit faster, and then make something generative, something fancy with it afterwards to see, okay, what can we do with the Kinect data and where can we plug it in. We also have to try to level it out somehow with the real beginners, because I can see like a lot of faces from the beginner workshop. I know that there are some intermediates who also expect something of this workshop. We will see how we can arrange it somehow to have everything, something for everyone. Yeah, if we are too fast, you can still raise your hand. We will come to you. I want everyone to be able to catch up mostly, and I hope that for the intermediates that there will be also something new for them then afterwards. Yeah.
Yeah, so let's use this time to catch up. If you if you feel like you're missing out on something or you have a question, let's take this time to do this.
Should we explain how to copy the contribution and everything? The recorder that after the break they can already press play and maybe that's it.
Maybe after the break.
After the break, okay. So yeah, of course nobody could follow now. Do you have any general questions before we start with the break regarding to this?
Or would you rather have like a 10-minute break, take a breath, or would you like to continue? A coffee break?
I have a question. How you define this spine base or some?
This is
How you define it?
I will show you again once you have everything connected on your machine. We won't send, we will only send you the values and not the names, but this is coming directly out of the Kinect 2 contribution.
No, I mean just the numbers. So join.
Okay, super easy. You show the slice index in the inspector.
Yeah.
And then you have.
I mean select slice separation. You need to write to select, for example, head slice.
I don't understand. If you want to see.
How do you pick
grab
the
the
singular
slice for the hand.
one
You
slice?
seem to know that it was going to be his hand.
Yeah.
So So how did it pick the hand and not its head?
That's why I'm going through the indices, which here in the list I can see that it was the index number 6. I know that with this spread concept, since every one of these indices is standing for basically 3 indices in the 75 spread, I know I have to jump 3 times 5. For example, we can use this minutes for explain the get slice one last time again. What the get slice is doing, it's giving me 1 slice out of this array. So if I want to have, for example, from index number 6, I want to have the x coordinate. I know that before I have 5, 4, 3, 2, 1, 0, and all of them have 3 coordinates inside. So this is in the end 6 times 3 is already 18 values. So the 19th value will be the x of my wrist left, if I want to go through slice by slice. But instead of going slice by slice and making all these calculations, I can go in increments of 3, and this is called the BinSize here. Here we got the single coordinates, as you remember. Here's the BinSize always 1, and here we went with the BinSize of 3, so I can jump really directly from the first XYZ set to the second XYZ set, and this is what I was doing here, and then I only have to tell it to which set do I want to jump, in this case number 6, and this I put here in the index number. So I jumped the index number 6 with BinSize 3, which means internally I was already jumping 18 values in this pure value list. Is this somehow, I know this is hard to grasp, and it would be better to have some kind of visual representation of
So in summary, like the Kinect has this predefined anyway, and in the contribution, because the developer knew which index is which joint, we have the list now. We know which index will be which joint, and thanks to the contribution, we can just follow this and say, okay, I need the head, so the head is number 3. I will take number 3. And this is not something we're now deciding, but this is done in the contribution to help you use this more easily.
Okay, and to compare it here, what we can try now, let's say spine base 0 is index number 0, 1, and 2 in the 75 values. So we have our spine base here, and we can see we get the same values. Okay, I will try to put it to the same size. These are the same values. What I'm doing now, by jumping in bin sizes, I will go to the next set of 3. And this is now index number 3, 4, and 5 would be, let's do it. Here, here we have the set of values. I will for now go back to index number 0. We do it here. Index number 0, the values are the same. If I go now to index number 1, it won't go only 1 slice and then taking the next 3 values, it will go in increments of 3. So with index number 1, I'm not jumping to the index in this series of numbers, but I'm jumping to the next set of 3s, which should be here. And if I compare the values, yeah, it's right. It's the next set of x, y, z coordinates. And I can now jump to index number 2. Let's see, I go another 3, which is 6, 7, and 8. And I have the same values here. So this is how I'm picking out from this list of spread of 75, which is giving me plain values without any idea if this is x, y, or z or whatever. I have to make sense of it by knowing, okay, I'm getting vectors spread with a slice count of 3. And so I can jump through. And because I thought the wrist left would be an interesting thing, I went to index number 6, which is, that was it, 6, 18, which would be 19, 20, 21. Let's see, index number 6, 19, 20, 21. And here we are. And this is our set. This is our set for the wrist coordinates. Yeah. Still not very easy, I know, and I had my troubles to wrap my head around spreads and slices in the beginning because I was coming from the code-based programming, and I was really happy with my for loops and indices and everything. It's a little bit different, but once you have understood it, it's making totally sense for visual programming, and you will like it in the end if you work more with vvvv, I'm sure. Next question? Pardon?
Like yesterday, we got the patches.
We of course. Maybe even that patch already. This patch will make not so much sense because you don't have the Kinect plug, but once you have the playback also, and you can copy paste it in there, you can use this patch and continue from there, maybe after the break. It will need some time to copy everything, set it up, and also set up our playback contributions. Maybe half an hour, but you will get all the patches, of course, that's for sure. We will share them with you.
Say, which Kinect 2 node exactly did you pick?
In this case, there are only two. In this case, I took the devices Microsoft because the point cloud is more interesting for people who really know how to work with shaders, because what you get here is the real basic point cloud data that the Kinect is recording. Because what the Kinect is doing, it's sending infrared rays over the scenery, and by detecting how long they take back, they know the distance, which is then giving you, depending on the resolution, just points in space. And this is the basic data set that Kinect offers you, and it's called the point cloud. And this is what, when you see this wonderful 3D simulations where the face is like a little bit distorted and this kind of thing, this is all made with the point cloud, where you interpolate some kind of mesh with the points in the space that you get. We won't use this because we are happy to have X, Y, Z and our coordinates of the skeleton to make skeleton tracking useful for interaction. Yeah?
Okay, thanks. The original question was because my Kinect 2 node is red and it doesn't have pins at all.
That can come out of several reasons. For example, maybe you don't have the DX11 pack installed already.
I have it.
You have it, then
The TDY does something with exception, but it's always like
a thick amount of exceptions and you cannot read them. Yeah. I don't know. I can try to take a look. I'm not sure if I can solve it.
okay, he's got the same problem.
A red Kinect node. Red Kinect 2 node is happening more often than we want it, but usually this problem can be solved. I think we can take a look now in the break or afterwards and try to solve it somehow.
The SDK.
Also this, of course, sorry. Yeah. Do we have it on the USB stick?
No.
Did we take the SDK also?
My impression is that people, because they have to stop following the
Yeah, exactly. So
they can't wrap their head around the.
we have to try it ourselves. Yeah.
So maybe we can do like a spread with the the morphing thing last time we did.
As a graphics explanation.
Just not really that maybe detailed, but just to have like explain transforms and then picking from a 25 like 5x5 grid.
And do you think that might be?
They like.
I'm sorry. It seems we have to install the Microsoft 2 runtime something connected on the V4 side.
Yeah.
He says.
That might be true. If you don't have that, I thought that the ones were already coming.
Like if we show this,
No,
we can
that's
just skip into the OSC version and then they have the same feed, so we don't have to play around with the recording first, and then after we do the OSC, maybe we can take the time to help people install, and then
In general, maybe going this OSC way is the best, because then they already have the values, and we don't have to take care of the playback and all of this connecting.
yeah, and maybe
We
if
just
you
have the
get
values
if
and
we can get
generative
your
patches.
computer to run the playback, then we can show the fancy movement.
Yeah, but I don't know why the playback is not running. That's the thing, I have no idea.
So like until the Kinect node, people were following the render and everything. We can show them like 5x5 grid of cubes. They just apply a spread to the box.
I'm just thinking if at the same time, while I'm explaining it briefly, you could already go around and help people with the installations.
Yeah, I am.
Maybe that, because then we have a very slow introduction to spreads again and geometry. So we make a break with the Kinect part, and while I'm explaining the geometry thing, you can walk around and help the red Kinect nodes for sure. Is that an idea? Yeah. I mean, I think everyone is connected to the nodes. No, yeah. Do you have a different internet? No.
I was just playing around with UDP, send and transmit. And if you want to, you can send it to the broadcast IP, and you don't have to have our IP addresses.
I'm not a professional with networking, so it's just a broadcast IP, it's like a .0. .255.
So 17.
You have to tell me. Once you tell me,
okay.
Maybe not now because
okay, sorry.
But thank you very much. This is the thing. Then I don't need to gather all of them.
Yeah. I
Perfect. And from the other side, you can also they can also connect them to this broadcast IP. They will get.
They can receive it. Hopefully, we can find later.
Exactly. That would be the thing. We were just talking. That's the way we will go now.
Okay.
Because setting every Kinect node up and everything, we can just send the plain values to UDP, and everyone can already have fun with these. Yeah, and then idea was to also show how it's working with the Kinect, because this is what people want to try at home with their devices. That's why it's something for the afternoon. It's exactly the idea that we have. After the break, maybe we'll start with the UDP. I will ask you for what to broadcast. First I have to take a look at,
Okay.
Networking.
Yeah, it happens sometimes. Or that stick for the runtime, hopefully.
Das ist nur die Runtime, das ist only the Runtime.
Ich meine, das ist die Kinect Runtime.
Ja genau, die weiß nicht, ja genau.
Die scheinen ja auch alle zu brauchen.
Ja. Da haben wir aber noch mehr. Wir haben 4 Sticks, falls ihr mehr braucht.
Ja, ich glaube, ich lade es gerade runter, es geht auch relativ schnell.
Aber ja genau, jetzt in der Pause, das wird sich schon ausgehen, oder?
Aber das müssen vielleicht alle wissen, dass sie so mal...
Genau, die das brauchen. No problem. Hey, you're welcome. I hope we can. You have some business.
Yeah, just connect this
they will do boxes, exactly. Yeah.
He introduced me with networks to
Oh, very cool. Yeah.
Yeah,
And now it makes sense. And as I told before, we are here not working with the soundbox because the hitbox is everything for because what these boxes are also doing, they're calculating how many points are inside this volume.
Yeah.
And we just make a volume where if we are...
Yeah, that's what I was looking for, because
just having same value because this box.
Not really, you didn't feel thanks a lot.
No, you're very welcome. And we will repeat another time and we will use the values the whole day. So in the end of the day it should be really No, if you want. I mean, if you find space and the plug on your desk, just bring it. Yeah, I did the same with the last one.
I'm just
I also
Du hast doch mal angerufen.
Das stimmt, aber hast du das schon drauf?
Das geht mir, das denke ich auch. Ich werde nochmal jetzt gleich hier, ich bin gerade drüben im Orange, aber ich werde noch ein bisschen sprechen. Und okay. Okay. Mhm. Okay, cool, dann fragst du nochmal.
Jetzt ist alles gut?
Alles klar. Ich bin jetzt hier auf dem Workshop zum 1, da komme ich immer für die 1,5 Stunden drüber. Was ist das schon gelöst?
Er hat schon gesagt, dass das einfach gleich installiert ist.
Ja, ja, ich habe die successfully
Speichern?
Ja. Ja, ich weiß nicht. Ich glaube, er hat meinen.
Was wäre? Ich weiß es nicht genau, ich würde mal sagen, L.
Und
Hast du eine falsche Version gestartet? Ich habe auf 6 drauf, weil immer irgendwas irgendwo nicht ging. Und du wolltest jetzt auf jeden Fall, ich würde sagen, was ist jetzt einer bei Markierer? Naja, gut. Aber das ist nicht alles, das ist nur ein Bruchteil von den Werken. Du hast ja mal vorhin, du bist vorhin eine Version gestartet.
Was?
Du bist vorhin eine andere V4-Version gestartet. Würde ich mal behaupten. Ja, weil ich meine, das sind jetzt nur die XL-Notes, die gut sind. Und die findet er ja auch nicht. Schon, ne? Ja.
plug is it okay if I plug like this?
Yeah, it's fine.
Because I'm low on battery.
Yeah, of course.
couldn't see it.
Ah, cool. No problem. Anyway works.
Frage, short question.
Yeah.
Kinect 2, I don't have that node.
No. Do you have the DirectX 11 pack installed?
No.
No. Okay.
I have to do that because I came in late.
Ah, okay. So basically, you need the DirectX 11 pack, and without the Kinect patch, you won't be able to use the node. But we have a solution and figure out if we install for everything.
Where do I get it on? Ein Sample und Hold, was macht der da bei der Liste?
Genau, der macht das, weil wenn wir jetzt kein Skelett haben, ich lösche das einmal kurz. Wenn wir jetzt nichts haben, dann kriegen wir nichts. Das ist nämlich, wenn der, so wie der Name sagt, der nimmt den Wert und haltet ihn,
ja.
Wenn man ihn einmal aktiviert, solange bis man ihn wieder aktiviert.
Okay.
So wie jetzt ist die Liste leer, weil gerade kein Skelett da war.
Okay, dann würden wir die Liste gar nicht sehen.
Dann werden wir die Liste nicht sehen. Und damit wir die Liste ständig sehen, habe ich den Sample and Hold String genommen.
Okay, alles klar.
Genau.
We have 1 hour before the lunch break.
Exactly.
Do you think we should just take this time to install for everyone, or we go with the basics and then after the break we start with installing the setup?
Also again, explaining steps a bit, taking a mesh and distorting the mesh a bit, and then look at transforms. That's a good idea.
Okay, and then after the break, maybe after people ate, or also like it's maybe hard to focus, so we use this time to get the setup for everyone, see if everyone can get the Kinect to work, and then we can use the playback patch, so people have the ability to see me on dance.
That's what we want to do, and maybe we come a bit earlier, a few minutes, and try to set up the UDP from our side, that they just can connect one and everything, because I don't want to do it within the workshop in front of them. setting up the UDP thing. Or should we show it? I don't know, because usually what I'm doing is also going to the word power patch, just copy pasting what I need from the UDP, and then sending it. Maybe we can watch.
It be a little confusing for them if they try to.
Maybe just use it for now.
Yeah.
Mm-hmm.
So
we'll start with the new patch and we will play around with meshes and vertices
and nothing with the Kinect directly,
okay.
and then the next step will be just
I
start
think
with the
that's a
setup,
good idea.
and then
Do you want to do
try
this?
to see if we can.
Do you want to do it?
I'm not really so soon actually. I
No
don't
problem. I will do it. It's very similar to the last 2 days. Kati was explaining and at the same time I was patching because she was doing it for 5 months already.
I mean,
If you're fine with this workflow, okay. No. Then let's do it. Okay.
Can I have again the stick with the files? Do you still?
Yeah, of course.
So there's, I have to search for the
I think this one has
for this video file or FB. What file is it?
XEF.
X.
Yeah. You can take all of them if you want. So you have diversity.
Okay, for now, 1 second. For now, the idea was to continue a little bit more with 3D basics and meshes and 3D graphics generation, and to continue with the Kinect playback thing and setting up all of the Kinect SDK and getting the red nodes away. We want to do that after that break, after the lunch break, so that we can have some more basics of how to work with meshes and vertices in 2D first, to have a more basic understanding without any peripherals for now. And after the lunch break, then really go step by step with the installation to have it running then maybe half an hour later and continue from the same point again. If you're fine with that, we will start with a new patch, play around a little bit with vertices and meshes, and take care of the peripherals and after the lunch break. Yeah? That's fine for you?
Also with the one?
Pardon?
With the one also?
Everything would work with the Kinect 1 also. Okay. But there's some differences with the installation and everything.
Yeah,
It's the best way to take a look on the vvvv homepage again, the forum, see how people treat Android Kinect 1. But of course, everything is possible also with that.
It will work as the same, right? At the end.
The thing is, it's much better if you have the second version because it's so much more stable and tracking more people and everything. Ja.
Hast du noch einen USB-Stick kurz?
Ja, wir sind jetzt gerade alle irgendwo unterwegs. Wir haben da noch einen. Wir haben jetzt aber, da drüben ist noch einer. Ja.
Ah, what's on this? The DX11 stuff? Yeah, great.
And I will try to save as often as possible if it's crashing. We have everything in there. And now it's fine, I think. I don't know.
Not so warm?
No, not so warm. Luckily it was cooling down today. Okay, that was really basic. Also something you might know, it's a technical thing, but it's I think not so bad to know how this is working because we had this problem already. For the Kinect 2, you always have to work in the 64-bit version, and if you want to switch between versions, let's say for example we open a patch, then we see it's a 34.2 64-bit, we can see it here. But now for example if we want to switch the version, this is done by closing everything. Then I go to the folder with my versions, and I know this is the version that I just used. So you go inside there, I again activate the setup, and here I click, don't take care of that, I don't know, it's still working, but here I click uninstall. In this moment I press uninstall, all of the internal connections in the system are getting deleted. vvvv is still there, there is nothing that is really uninstalled or so. But now it's not automatically opening with this version because I want to have my patches being opened with another version, and this might be now a random version, let's say 35.2 64-bit. I open the setup here, and just by opening it you see I can have all of these connections are done again, where I am now in the 35.2 version. I can do the same again, I uninstall here. I go back to my other version, open the setup. Just by opening, it's again connecting all the files in the background to the version that I want to use. This is very handy, and sometimes you have things that only run in the 32-bit domain, others only work in the 64-bit domain. You cannot mix them up. That's the problem. If you, for example, want to mix up some older libraries that are or externals that are only possible to use with 32-bit versions, it might be a problem because you cannot use them with an interactive Kinect patch. But there are workarounds, I won't talk about them, but just to let you know how to switch between 64-bit and 32-bit, for example, if you have to do it once in your projects. I will now go with the version that I had before. You can take the one that you had when you came to Node. And I will just open a new patch for now. Let's see what we can do. So 3D and graphics pipeline. Since I'm also, if it's not directly working with connectors or something very special library, I'm usually working like it's supposed to be with the EX9, like the DirectX 9 environment. So here we will now, for this example, we will switch to the DirectX 9 domain, where things are a bit easier. Really, it's minimal difference, but just in case I forgot some notes there. So of course we start again with our output. We need a renderer EX9. We need a group to be able to display some different objects. Just in case, I will extend my group with Control I open the inspector. I tell him to give me like, let's say 4 or 5 layers. Whereas here probably I don't need more than one, but just in case to see how this is working. Okay, and now we want to have some geometry, and then afterwards see what we can do with the vertices and the geometry itself. So one of the easy geometries is a grid. A grid is, as it's saying, is giving me a grid of vertices, like a matrix of vertices, two-dimensional. I can choose in this grid how many vertices do I want to have on the X, and how many do I want to have on the Y. Here I will say I like to go with something like 10 by 10 for now. As you can see, I get in the end a mesh. This is our basic geometry in vvvv. To be able to display this mesh, I need a shader again. This time I will take the constant. It's fine for now, I think. Constant is not dealing a lot with light or special specular behavior of the material or something. It's just giving a color to my grid. Let's see the group. And here I can see the grid. Then I always have to look them up myself. I need a render state to tell the grid how it should be displayed. In this case now by default it's displayed like solid. This is why we see a quad. But the quad itself is consisting of 10 vertices on the horizontal times 10 vertices on the vertical. And we can see it by changing the way of rendering to wireframe. And here we are. This is our basic geometry, how the graphics card is getting the information of the corner points called vertices. This is where I have to put my material on. Render state in. Okay. Then we will take transform. Let's stay with 2D. Here we have a transform. We can translate, scale. Let's do it, I don't know, we can scale it around a bit.
Sorry, which transform did you do?
So here we can make a break and see questions.
The transform, which one did you do?
This is the transform 2D because I'm still looking at the two-dimensional plane for now. You can take the 3D, you will just not see any change on the X coordinate changes. So I have a mesh here. And this is our basic geometry. So also you can see a very crucial point of how the graphics card is working, because what we have here, we have like 10 times 10 vertices. But the graphics card can only calculate in triangles, because every vertex has to be connected with adjacent triangle vertices, so it's splitting up all of our quads into triangles. We don't have to bother with it, it's just for you to know this is how a mesh in a graphics card is working basically. It's built up, it's split up in triangles, and on these triangles then, if we have a material, for example here we can then choose the render state to solid. In the moment when we apply the solid, now we're giving it some kind of color. Here you can see the color is plain white. Let's, I don't know, let's make it something different. So, and now we'll go back to the wireframe. So here you can see the color is applied to every vertex in the shader and interpolated between these triangles. So this is what the vertex shader is then doing. First, no, the pixel shader, sorry. First you have the vertex shader. This is calculating all of the corner points that you need to know where is my geometry on the screen or in space. And here, if you have the wireframe visualization, you can see which color. Now this doesn't make much sense because we have plain blue, but you can imagine if there would be a gradient, it would always take the position of this vertex, and this vertex in the triangle, and then in between interpolate a gradient, and this is then happening in the second step of the shader called the pixel shader, where you have the positions and where you want to see, okay, now I have this many pixels, I have the positions of my vertices, and in between I want to know what's going on there and how it should look like. I will show you a funny thing. Now we have this 2D scenery, but vvvv doesn't care if it's 2D or 3D. So what I can do is, for example, what we know from before, the node is called transform soft image, because I can move inside the screen. I will connect it again to the view, the second output pin view, to the input pin of my renderer. Same thing here. And now we can see that internally, it doesn't matter for vvvv. In the moment we apply a camera, everything is calculated in 3D. And again, we have a 2D plane in a 3D environment. So, okay, let's see who is where. If you need to know the name of the node or something, just raise your hand.
If you would want to combine the grid and the solid color, you take two constants or kind of spread them into the render state.
You want to display onto the full colored plane, you want to display the wireframes then? Okay, how would you do it? I mean, you could make a texture that's having this wireframe thing and just apply the texture. Okay. Or in the end, what you would do is having two objects on the exact same position with the same transformations. It would look like that. But then we're coming to a problem that we didn't see yet, because for 3D, for example, let's delete maybe the camera and I can show you. I will save this batch for a second and we can come back to that.
I didn't want to make it too complicated, just...
No, it's a matter of, I just have to say it's a matter of 1 minute or so. You can already see where this is supposed to go. Okay, I will delete the camera. and we're looking at the plane again. And if we have like a 2D thing and 3-dimensional coordinates, I don't remember the name, I think a set collision or so. It's a problem because if you have two planes on the very same distance in the set, they will start to overlap and you will have a lot of weird effects. So this is not very easy to do. You can like put it one 0.0 something on top of it, or so that you can have both displayed, and then you could see that. Even if they're the same color, you won't even see the triangles then because it's the exact same color. But in this case, you would copy paste, you would put it into the group. Let's try. Now maybe we can see the C collision already. Okay. Okay, for now it's working.
Yeah, but that's because 2D renders it in the way it goes
Translate
into the
set.
group, I think.
Okay, we don't see this effect here, but this is in computer game engine development. This C overlapping effects, they were a problem for some time, and just to have it in mind, try not to have things totally overlapping because you will see weird effects if you're rotating them also. Okay, now we have a mesh. Let's go for understanding. What if we want to make some kind of noise inside, or we want to give this mesh some kind of dynamics? We want to access the vertices themselves. This is like the next step to understand the geometry or so, and this is what we will try to do now. We will take the mesh that's coming out of our grid node, and we will try to access the specific vertices and make them move around and see how the mesh distorts. There are some notes for that. It's very straightforward workflow. We had it in the beginner workshop for a moment. And let's see. Okay, we have the width. Geometry split. Okay, first step is we take the mesh and we split it. This node is called geometry split, and what it's doing, you can see we have the vertex buffer. In this buffer, all of the vertex positions are stored. They are having indices and IDs. So the graphics card needs to know for all of these packages of threes, they have to know which ones are connected. So this is why they get indices and everything. For now, we don't need more than that. Okay, I don't remember the name. What's the name of the mesh split? Do you have it open? Otherwise, I will open my patch. I'm sorry, I have to look it up myself. Let's see. No, it's not that one. Okay, now I have to find out what was the name of this. Also not. Forgot the name. No. Do you remember?
I can't find the one
We we had it yesterday. Yeah. Yeah. That's just a good show of effect. I don't remember. Nope. Was not. Okay. Yeah, that's it. Just vertex buffer vector. Mesh vertex buffer. That was it. Talking about it and forgetting it at the same time is very cool. Vertex buffer. Okay, the node is called vertex buffer. Sorry for that. The vertex, exactly what I was talking about. Of course, there's a buffer that has to store all of the vertices. Okay, I could read the output pin also. So here we have the vertex buffer. And there's always two versions because at one point you want to split it, and after you have made all of your transformations, transitions, whatever you call it, you want to join it again to be able to calculate in the renderer. So these are all the split versions. You see mesh geometry split, vertex buffer, geometry split, and the same thing we will use later, the join. Okay. So, here we are. You can see we have 300 values. We have 10 times 10 vertices. It's like 100 vertices. All of them have an x, a y, and a z coordinate, which is giving us 300 values. And here we have the positions now in vertex form. Let's see what we can do with it. Now we need a... This is what I could have looked up before. Vector 3D split, okay. The vector 3D split is our next node. Here we have the 100 vectors, 300 values that are coming out here. We can split them into their x, y, and z coordinate, and so we can attach all of our x values, all of our y, and all of our z. So I will connect my 3D camera again to see some kind of effect. And here, let's say what we could do is, for example, we leave all of the positions like on the x and on the y, we leave it at the same place, but we want to make them move like up and down on the z axis, so that we have some kind of distorting mesh. And we can do that. First of all, we stitch together our mesh to always see what's coming out. Vector 3D join is here. We connect our x, our y, and what we don't want to connect is the z, because this is the one that we want to manipulate. We need the vertex buffer again, where we will store the values now joined. We also need to know the normals, so we will connect them here. Then we want to join it together to a mesh again. Hope I didn't forget anything. Let's see. Let's see what's gonna happen. There we are. Okay.
Any questions so far? Are you guys following more or less?
The screen is black for some reason.
Did you connect the mesh?
You missed one connection. I have to explain again because I was just looking at myself. I'm sorry. You have to take some values also in the join. For example, once you have the vertex buffer join, you cannot only you need more than only the positions. The vertex buffer also needs to know the normals to see from which side do I see the plane and from which side not. So from the vertex buffer split, I have to connect the normals, my 300 values of normals, inside the vertex buffer join to keep the information of the normals. This is one step that I didn't tell you now. And it will probably still be black because what you need then is also the information about the indices, which is belonging to what, and I take it from the mesh geometry split and put it into the mesh geometry join again on the pin with the indices. I plug it into my constant and a constant into the group, and I will have it displayed there. So who is not able to see the quad in the renderer, then I will come there and take a look.
Second.
Yeah, but
press the controller out.
Okay, as far as I could see, everyone can see the mesh. As we split it now, and what we want to do is now influence the set value to make it somehow noisy or something. If you remember from yesterday, maybe there's something called the random spread, because we want to have random values. We know that we have 100x, 100y, 100z, so we want to have 100 set values, which should be randomly spread around somewhere. No. Not at all. And there we are. So on the set, this is our mesh, and as you remember also, maybe you can give it a seed. So if you jump, for example, to seed number 1, we have a different mesh. Now we want to have it animated, which is always the most classic node in vvvv. Let's take the LFO, and the LFO is giving us with every cycle another number, and we can use this number for the random seed to get the random to get new random numbers, which would be looking something like that. This is also still very discrete and not very organic or nice to look at, so we will use the damper again, and maybe in this 10 minutes that we have, I would like to show you another filter that I find very interesting. It's not working in every case, I hope in this case it does. Everyone who is maybe involved in music synthesis or something knows it already. It's the so-called attack, decay, sustain, release. So you can decide how far do I approach the target, how long do I stay there, how far is the fall off to the next value, and the release. It's sustain, decay, and release is very similar. We can try it with it, or just that you have seen it. For now, we'll take the damper. And we have some kind of almost organic moving random structure mesh. Now I will detach it. You can see it bigger. And this is still like, yeah, looks cool, but I would like to have more points. So I want it quadratic. I can use this for the x and the y. I will tell the grid to be like 100 vertices, which means also here we will get 10,000 x, y, and also we need then, of course, 10,000 different random values. And we can do that just to have one central parameter to change everything. We can say times. We take the amount of our vertices, multiply it by 100, and put this, and let's see what's coming out. That's too much. Okay, that's too much. We can go back to, let's say, 30. And here you can start to play around and with the values. Let's see what was there always in top shortcut? I don't remember. Let's try with 20. Then it's too noisy, it doesn't look very nice. I also want that it's not going that far in the set direction, because what I have is some mesh that I cannot really see. So I will try to map my values, because they're jumping too far. I know that I get values from width. 1 means I will get values from minus 0.5 to plus 0.5. I want it to be less, So I will take the values that are coming out here. And I will map them down, like the destination minimum should be less. Just something like that. So now, time to tidy up. And as you can see here, we just left the Z coordinates away and replaced them with our custom-made coordinates to give the structure more dynamic. Do you have any questions? Is anyone stuck somewhere?